Now that it's theory, we should use the normal distribution as we used the last week. And we input, let's see, we can know it's the x here. It's the mean is 10. The variance, still remember, is 3.1, I think it's 1/6 something, right? Anyway. Here, what should we use? We select the true or false. True, what does the true mean here? So this is the normal distribution. What does the true mean here? Well, because we, well, even you use SAS, you still understand this, you know. It's the normal distribution. Let's say this is 10. So here is 10. The variance is 10. So if we say here is 6. So now we are doing, of course, there's a function here, px. And you still remember. Anyway, so this is the function of this curve, and here is 6. So what does, if we select the true there? What does the,
if we select true, then it means our data should be in between 6 and 10, right?
please remember here the now is I5 is 6. 10 is the mean of the distribution, and another the 3 actually is the square root of 10. Okay, now well, let me end. So what does this value tell us? Is 0.5 something. 0.5 is what? It's this height or some area. It's a probability. So the true is it will give us the probability. So what is the probability? And by using this curve, what is the probability at this level, at the 6, at this value? Remember, it's this tail area. Okay. So this is the area actually is the probability. Let's say here if I use force, what does the force? If here I put a 0, what does the 0 mean? Anyway, let's see the value. Actually this, maybe before I did the, before I should input a 1. So if I input a 1, so it's the, if I input a 1, so this is the probability. It's the area. So if I input here 0, which is the force, so what does this value mean? 0.5. Remember here I select the force. So the 0.5 is what? point 5 is just the height. Okay, let's see here. Here maybe 0. It's like a y. It's x. So now it's the 7-point summation is the height here is the y there or the height here. Understand? No? Why? I don't know why it's that hard. Okay. So here, what we want? We want 1 or we want 0? Guess. So this value is more like a probability or like something like a density. So is this a probability? So probability is always accumulative. Once we have everything, probability should be 1. So this it can be look at the probability. It's a probability at some interval. It's a probability, in some group. It's similar like a density. It's not accumulative. If you want accumulative, you should add something up. So here actually we want the. So later I will see that there are some difference.
Tell again when we need to set 0 and when we need to use 1.
Okay, exactly. So it depends on what you want. If you want the probability, if you want the probability, you need to select the 1. You want only the height of this line, you select the 0. Okay, so if you select the 0, it's exactly this formula, what this formula tells us. If you select the 1, it's an integral. Integral from the minimum value up to this point. So that's why I said it's an area. Okay, so then you just drag down. Okay. So as you can see, it's not exactly same, but maybe 100 is not large enough. Let's say if we want to draw these two lines together, we select the to insert. Anyway. What graph do you have? It fitted very well, or it's similar like a man? Yeah. So if we increase 100 to 1,000, it should be much more fitted. So there actually is another problem here. We should do some adjustment. For this f value, we should be plus. We should plus half. After that, it will be much better. So I think, especially if we have a very large sample, y plus half, because this value is actually is between 7 and 8. So this value, oh, yeah, yeah, this value actually is between 7 and 8. So the middle point, the middle group value, should be, yeah, is 7.5. So it's better, that's why here I do some adjustment on the web. Let's see what's the distribution here. Okay, for clear, I remove my figure. Now let's see. I remove everything here. Except the okay. Now next, let's see this distribution. As we said before on the slide. So this actually give you a chance if you don't believe some statistical theory, you do some validation. You can do some validation. Let's see where is it. Hmm? Okay, here we go. So next we basically I said that this is very important. So through simulation we see the distribution of sample mean, right? So the sample mean is the relationship between a distribution of a sample mean and the population distribution. And then now we see the sample variance. Sample variance multiplied by n minus 1 divided by variance is a chi-square distribution. That's what we are going to do now. So here I make a note. It's n minus. Anyway, I just use SS actually. Uh, Once we do this, it becomes a sum square. I do a sum square divided by VAR. No, not maybe sigma square. Hmm. Anyway. And okay, what's the sum square? Sum square is actually sample variance multiplied by degree freedom. What's the degree freedom here? What is the degree freedom here?
100 minus 1.
No, I mean for the favor data point. I'm talking about the you know the sample variance. That's where the sample variance of only form of favor data point. Yeah, it's a 4 and divided by what's the population variance? The variance of the population. What's the variance of population? When we do the simulation, what is the variance of the population we simulated? It's 10, right? So here, divided by 10, actually give us this value. This value, if we consider all the 100 or more, it should be follow a chi-square distribution with a 4 degree of freedom. So next we find all the for the 100 of this value. The 100 of this value. We just drag down. We have 100 of them. Again, you find the minimum value. Like now we want to draw a frequency distribution. How does the frequency distribution looks like? Ah, okay, you go ahead, find the minimum of the 100 values. We just find what is your maximum value. What value do you have? Okay, Yeah, we should have a very similar value. Maximum map computer is 13. You should we also have something around 13.
You have 1.38.
Ah, 1.38. I mean maximum. So this column is the G column multiplied by 4 divided by 10. So and what value do you have maximum? Now we make a group from 0 because it's a normal distribution. 1, 2, no, 2, 3, 4, 5, 6, 7, 8, 9. There's a lazy way actually. You can just input the 2 and you drag it down. I think then you go ahead, find the frequency. We want the percentage just divided by 100. Are you here? Who is here or who is not? Are you here yet?
Okay, and then we haven't used the chi-square distribution, so we want to use this function now. It's called chi-square. Again, you see a lot of similarity. So just guess the frequent distribution T, F, normal, binomial, some Poisson, whatever, and then will come out the similar shape. So the distribution, there are some more actually. When we do the normally for the probability, on the left set, it's always it's use this one. But sometimes when we do the hypothesis test, we want the significance probability. Basically, it's the red tail. So sometimes we want to find the red tail. This again, in the F distribution. So if we use this one, we will find the area on the left. If we use red, RT is red tail. So this is the probability on the red set. Basically, is if we want to find the area on this set, so we should use this function. Okay, so now we use the first one. We select X, and then we select the degree freedom. What's the degree freedom here? 9? What's the degree freedom? Degree freedom is 4. So accumulative all the for this special case, this does not like a probability. Because probability is keep increasing. So this like a density. So here we use 0. You input 0, and then we will have this function, and then you drag down. You find all the value, and as before, you can draw the two lines to see how good. This one it fitted the there are some variation, but in general you see the long tail. So after the class you can try more. You can try more. Then this like this is the theory. This observed. So how is your graph look like? Same as this? Okay. So I open another sheet. We will see the sum because we up to now we see binomial, we see normal, we see chi-square, we see we haven't seen T and F. So I just open a new sheet. So we find some the distribution of T and the distribution of F, so we can finish it today. Let's say we want to have the T distribution only 1 degree of freedom. This is like an X value. We just draw maybe 4 degree of freedom, okay? And the X, so the T distribution, what's the range of X? It's a quiz. I mean, what's the possible range for the T value, T distribution? Can it be negative? Yeah, I mean T distribution. What's the possible range for the T distribution? So what's the range for the normal distribution, standard normal distribution? 0 to what? It cannot be negative. Normal distribution, where it cannot be negative. Standard normal distribution, I should say. What's the mean of the standard normal distribution? What is the standard normal distribution? Normal distribution have two parameters. One is the mean, another is the variance. So what is the mean of the standard normal distribution? What is the variance of a standard normal distribution? Nobody knows. Nobody knows. Nobody knows. We all fails. So why it's so hard to determine? It's a standard normal distribution with mean of 0, variance of what? So for the normal distribution, the possible value can be from a negative infinity based up to positive infinity. It can be any number. But of course, the most value should be around 0 because the mean is equal to 0. The variance is 1. So you still remember the very first class we talked about the probability within 1 sigma range, 2 sigma, 3 sigma. You still remember 3 sigma principle? Don't forget everything after the class, otherwise it's hard. At least you still there are some very basic things you should remember. So for the t value, it can be from negative infinity up to positive infinity. Of course, again, the t distribution all around the 0. When the value is too big or too small, the probability is close to 0. We cannot consider that. Let's say we have the value from -4, and every 1. So we draw from -4 up to 4. Okay. Let's find the function of the t value here. What we are going to use is t. When you type t, so the t distribution will come out. Of course, this function also gives us more choice. If we want to find the probability in two tails, you use this one. Probability in the red tail, you use the RT. Of course, left tail, this function give us. It's always by default. If we don't specify whether that's the tail, it always means the left tail. Okay. So the t distribution, and we select the x. So here we talk about the degree freedom 1, and we talk about the density function. So here we input 0. Okay, so you can similarly you make you just drop down. So here you can make another degree of freedom. Select the x, degree freedom 2. Again, it's 0. T. Select the x, 3, 0. Yeah, please use your hand. This not I don't need to do the exercise, you know. Please follow me as much as possible. It's just repeat the same machine. Here I input 4, 0. So everywhere you what you change is the degree of freedom. So there's no hard formula. So just you type some letter, type some number. Mm. Yeah, use your hand. You just make one, and then you select everything. You drag it down. You have everything, and you select all of them. If you want to see the graph, so we see the graph. Of course, we see some. We want to make it more smooth. So one way is you can make this group size smaller, not every one, but every half. And then we will have more data point. The graph will be smoother. And I think in Excel you right click your line, and I think there's one option. Let me see where it is. Okay, here it is. You point any of the line, you right click, you go to the end, the serial format, and you go to the line style. The last one, you can see it's get smooth. You try that, you see it become smooth. And you need to one by one. So if let's say we just select the first one, actually it's like smooth. Okay, can you follow? You never make any figure in Excel. Where did you lost? Do you have the data? Do you have the insert? You select the graph you want to draw. Okay, how to make it smooth? Let's just only select one column. You click the line. Well, the Excel most of the time you right click. You always have whatever you want. I think the last choice, and then you can see there's the one called the line style or whatever in your computer. Find it, line style, and here this is the smooth. Okay. Okay, so we just make a one F graph, F distribution. Let's see, anyway, the degree freedom maybe 1, 5, and 10. The F distribution has have 2 degree of freedoms. Hmm. Okay, be quiet. Follow me now. Follow me. So now we are talk about the F distribution. So what's the possible value for the F distribution? Can it be negative? Nobody knows
I think it can be negative.
how it come from. F distribution come from k-square distribution. Can k-square be negative? K-square distribution, F distribution cannot be negative. So we can start from 0, 1, 2, 3, 4, 5. Anyway, we just make a few, maybe up to 10. Okay. So this function called f(dist), and we select the x. We tell the 2 degree of freedom, and here is 0 again. Try in your computer. I don't know why it's harder. You just is equal f dot dist bracket and select the something. This is exactly the computer was designed for. So at the beginning, it's designed for calculation, not just for word processing, for play music, to watch a movie. Mm. It's designed for mathematics, for statistics, and for. Okay, you got it. And then we drag it down, so we have all the values. So if you want to see how the F distribution looks like, you select the data, you insert, you see, yeah, it looks like this. If you give some negative value, the probability will be 0. Again, if you want to make it smooth, you click the line, click your line, right click, get data format, line, smooth. Okay, it's become much better. So I think the figure in Excel is good enough for publication. Okay, that's it for today.